Topic 5, inverses of radical functions. The first objective in this topic is to find the inverse of a given function algebraically. There's two other ways to find inverses of functions, but the first one we're going to use, and again, the first objective in this topic, is to find it algebraically. Okay, so to begin, we're going to go through some notes to find the inverse of a relation that is given by an equation in x and y, where the variables x and y are present. You switch the x and the y and solve the new equation for y. So right now it might not make a lot of sense, but we're going to put it into action in just a second, and it'll make a lot more sense then. It's important to note that the variable y, like y equals something, might be disguised as f of x, or g of x, or h of x, or z of x. It doesn't matter. It's just function notation. It's labeling the function. When that happens, when it's written as f of x, just write y instead. And so I put that as the first step. The notation for the inverse of f of x. So when you're finally done with this process, you have to label it correctly. All right? So it's f inverse of x. This little f to the -1, that -1 is not necessarily a power. It's just the notation of inverse. F inverse of x. So when you're done and you get your final answer, you have to write that as your notation to signify that you are done. You're going to signal me or anyone else that you're done and you found the inverse. One last piece of information, because we're going to be working with graphs of inverses as well, is that the graph of the inverse in relation to the original function is symmetrical about the line y equals x. All right, so we're going to look at the graphs as well in this process, because that'll help make sense of what an inverse is in relation to an original function. But first, again, this objective, we're going to find them algebraically, and then when I'm done, I'm going to graph a few of them just to show you more about what inverses are. So the steps that I've listed out in red, and again, just like anything else, follow it step by step just like I do to ensure that you can master this objective. The first example, the I do problem, I have f of x equals -4x plus 3, and it says to find the inverse. So the first step, again, I've already said, but we're going to switch f of x to y, just so I don't get confused, all right? So I'm going to, instead of writing f of x, this notation, because a lot of times that's given to you as that function notation, I'm going to write, this is my first step, I'm going to write y equals -4x plus 3. Did step 1. Moving on to step 2, switch places, the places of x and y. And we're going to talk about that more importantly, because right now it's just a step to you, but the inverse, it's a very interesting relationship between the x values of the given function and the y values of the inverse, and vice versa. And we'll notice that more when we graph it. But to switch places, I have an x right here, a y right there. And so I'm going to write x equals now -4y plus 3. I'm done with step 2. All I did was move the x and the y locations. All right. Then step 3, solve for y as you would any equation. Remember, the inverse of a power is the root. And we'll get down with that. I'm going to do 2 more I do problems in this video. And this step 3 might look different, just depends on what the given function is. But for this case, when I solve for y, the y is on the right-hand side, and there's a 3 with it. And there's a -4 being multiplied to it, but a 3 being added to it. I have to kick out the furthest thing away, which is the 3. So I have to subtract 3 to both sides. That cancels it out here, and then it becomes x minus 3. There's nothing to combine with that -3, so it just becomes x minus 3 on the left-hand side equals -4y. One last step, that -4 and the y are being multiplied with each other, so I have to divide by -4 and divide by -4. -4's cancel out on the right-hand side. Now I'm going to write, again, I know the y is on the right-hand side. It doesn't necessarily matter. I'm going to write it on the left-hand side now. Y equals, just like f of x equals up here. So y equals, in this case, x minus 3 is being divided by -4. When this situation happens, I can write out 2 division pieces. So x is going to be divided by -4, and -3 is going to be divided by -4. So I'm going to have x divided by -4, and then minus 3 divided by -4. Just to show the process a little bit more, because we need to find the slope, and now the slope is by itself with the x in front. All right, this looks a little bit more like slope-intercept form. Now, finally, to simplify this as far as we can go, x divided by -4, I want it in fraction form, so I'm going to write it right here. I'm going to have y equals x divided by -4. Technically, there is a 1 always in front of the x. It's 1 times x, but you don't have to write the 1 because it's just itself. But in this case, I want the 1 because it's going to look more like a fraction. 1 divided by -4 becomes -1/4. And then the x just stays in the numerator. So now I have -1/4 x, and then -3 divided by -4, negative divided by negative becomes a positive, so I write plus. 3 divided by 4 is just 3/4. I leave it in fraction form. So my final answer, I've solved for y. I did step 3. Y is now by itself. I'm going to use proper notation for the answer. And again, the proper notation to identify the inverse, because technically I'm saying this function down here, y equals 1/4 x plus 3/4, is the inverse of the given function up here. So I have to make note of that by writing, I'll do it in blue to finish it off, f inverse of x equals -1/4 x plus 3/4. And I am done at this point. Again, that process and your answer might look different. In this case, we had fractions. We won't necessarily always have fractions. It just was based off of the original function that was given to me. But I did step 4 as well. I used proper notation, inverse notation. I put f -1 of x, or the f inverse of x equals -1/4 x plus 3/4. So at this point, I am done. Now, I want to show you a couple things in relations to the graphs of these two functions. And so I'm going to have you follow along with me as I do this process as well. I want to show you what it means to have it be the symmetrical about the line of y equals x. If you would open up a new browser page, and I'm going to go to my internet here, I'm going to go to desmos.com. I'm already there, but I'll type it in again to have you see this. Desmos, so DESMOS.com. Alright, so follow along, please get to an internet page and type that in as well. You hit enter. Leave this page for now. It's going to show me the same page as showing. This is what your page should look like when you go to desmos.com. Alright, it's an online graphing calculator, and all I want you to do is hit start graphing. At this point, it brings up an option where you can type on the left hand side, and then a big XY axis graph on the right hand side over here. And so I'm going to type the first function that it gave me, f of x. So please type this along with me, but I have to remember what it is. F of x equals -4x plus 3. So f of x equals -4x plus 3. There's the line of f of x equals -4x plus 3. It's red. The slope is going down. It's given you the y-intercept and the x-intercept. Please keep in mind of those two things, because again, the inverse switches the x's and the y's. So let's look to see if this is in fact the inverse, and it should be the reciprocal about the y equals x line, and I'm going to type that in as well. But let's type in our inverse that we found. So f inverse of x, in this case I'm just going to put a different notation, g of x, just because it's another function, so the computer will read it nicely like that. G of x equals my inverse that we found, which is -1/4 x plus 3/4. So I'm just going to type that in, -1 divided by, or the slash sign underneath the question mark, divided by 4. Then I'm going to scroll over, so 1/4, and then I type x, so -1/4 x, and then, what was it? Plus 3/4. So I put a plus sign, plus 3 slash sign, or divided by 4. Alright, so now we have two functions. One's in red, one's in blue. So far, so good. If you notice, this is now the function, the blue line is the inverse that we found algebraically. The x-intercept of the inverse, 3 comma 0, is the y-intercept of the original function 0 comma 3. And if you notice, the original red, negative 4x plus 3, its y-intercept 0 comma 3. The x value is 0, the y value is 3. If I go down to the inverse line, the blue line, and click on its x-intercept now, you see that the x and y values switch. It's now 3 comma 0. That's true for any point that exists on either line. The x and y values switch when it goes from the original function to the inverse function. And key graph features, the y-intercept of the original function becomes the x-intercept of the inverse function. Just very important pieces of information to note, but it's also very interesting that that process happens. And the last piece of information I gave you is that these two functions, the original f of x equals negative 4x plus 3 and its inverse g of x, we typed out, they should be reciprocal, or symmetrical, I'm sorry, about the line y equals x. So that's the graph of y equals x, so please punch that into your computer as well. That graph comes out in green. And so at this process, if you notice, symmetrical meaning it's the same on this half of the green line as it is on this half of the green line. And if you notice, it's the exact same thing. Let's look at a couple other points just to see. I'm going to try to find out some whole number points. I'm going to go for my original function, my red function here. I find that at this point up here, let me click on it. Negative 1 comma 7. That's a whole number point. It's a point on the line. Negative 1 comma 7. Now, negative 1 is the x value. Where'd it go? Negative 1 is the x value. There. 7 is the y value. So if I go over to 7 as my x value from my inverse function in blue, and then negative 1 as my y value, which is right here, 7 comma negative 1, you see that the x values and the y values have switched, and it's true for any point from the original function to the inverse function. And so that's why this rule exists. That's why they're symmetrical about the line y equals x, because you switch the x and y values from the given function to the inverse of that function. And if you look, it makes a really cool picture, a really cool image. It is exactly the same on the top half of the green line as it is on the bottom half of the green line. So they're symmetrical about the line y equals x. And so for your practice of this, I'm going to have you find the functions algebraically, or find the inverse of each function algebraically. Then I'm going to have you come into Desmos and graph them and see what they look like, to see if they actually are inverses of each other. So go ahead at this point. I'm going to do the next two I do problems in a different video. So go ahead at this point and try the you do problem on your own, and then try to graph the problem into Desmos. So yeah, graph the original function and its inverse that you find algebraically into Desmos. So please pause the video and try both those things. Alright, at this point you should have paused the video and tried this one on your own. And here's the work I did to solve and find the inverse for this number 2. F of x equals negative 2x minus 5. The inverse I wrote down in red down here. F inverse of x equals negative 1/2 x minus 5 halves. So I showed my work. If you did not get this for your answer, please raise your hand. And again, the answer is in red down here. And I will come by and check your work to make sure we're on the same process. At this point then, I went into Desmos and I graphed both lines. The original function, f of x equals negative 2x minus 5, and this is something I asked you to do too, so please check your work with mine. And then g of x equals negative 1/2 x minus 5 halves, the inverse that I found algebraically. If you notice, they are indeed inverses of each other, because they are symmetrical. The top half of the green line is the same exact thing as the bottom half of the green line. Just visually you can see that. But a couple key points. The original function, the y-intercept, is negative 5, or 0 comma negative 5, which is the x-intercept of the inverse. And if you notice, the X and Y values switch. Now it's -5, 0 for the inverse. If you did not get this, please raise your hand and I'll come check your work.